Hello everyone, and in this video I'm going to explain the three contracts which are supposed to be explained for this coding challenge. So starting with the simple storage. So simple storage is a contract which is having one state variable called x and the two functions. One is set, which is available publicly, I mean externally, ideally. And then we have like another function called get, so which can be called both from inside the contract and outside the contract, and they're coming to the logic of set function. Anybody can actually call this set function with the new value, and then x would be updated to the new value. Coming to the logic of the get function, anybody can call the value of the x state variable. Okay, so that's all about this simple storage contract. Moving on to the next contract, which is the ballot contract. So effectively, ballot contract has this um, couple of state variables and couple of functions. So starting with the voter struct voter. So is the first struct, and then we have this proposal like struct, which is having this name and vote count as its value, as its parameter. And then we have got three main state variables. One is chairperson, the other one is voters, which is a mapping, and the third is a proposal, which is a dynamic app. It is recommended that the dynamic size be limited to few number rather than endless. And then we have got a couple of parameters in the voter struct, which essentially is very much required during the functions logic calls. So we will get into that in a bit. And so starting with the constructor function. So constructor effectively allows us to set some of the, basically initialize the contract after deployment. So whoever is going to call the deploy the contract, then the person is going to be the chairperson, and then the voters, the weight of that chairperson would be set to 1, and then we are going to populate the list, proposals list with the names which are passed inside the constructor function, which is this proposal names. You can see that there is a bytes 32 byte array, and then we can populate this proposals with proposal setting the first parameter, which is name, to the name which is set over here corresponding to each of those respective indexes as the loop runs. Okay, moving on to the next function, which is give right to vote. So give right to vote is allows the chairperson to give the permission to anybody. Okay, and so there are a couple of checks before that final voter state or voter's weight is actually set to 1. So we have to check if the function is being called by the chairperson. We also have to check the person who the vote who is going to get the right to vote is already voted or not. Okay, has already voted or not, and then the weight should be also equal to 0. Moving on to the next function, which is a delegate function that allows any voter to delegate its vote to another voter. So effectively, imagine like, for instance, we have Alice who is wanting to give its who is planning to delegate its vote to Bob. So we need to like check some of the concerns. So we have to do some of the checks initially, and then we'll have to do some of the setting of the state variables. So starting with like sender. So sender is effectively this. You can see this voters of this caller, which is Alice, is we need to get the details of that, basically the struct. Okay, so let me try to split it, and then it will be very easy to see. All right, so we have this struct. So this struct of the Alice, we are trying to get it over here, and then we are going to check if that Alice has already voted or not. Okay, and then we are going to check if the Alice and the Bob address are matching or not, because self delegation is not allowed. And then we would check if that loop in the delegation is found or not. So imagine, for instance, like Alice, who is trying to give its vote to Bob, delegates vote to Bob, then Bob delegates to Alice. So that sort of looping is not allowed. And in order to find that, we would have to run a while loop sort of. And then that's how, you can see over here that Alice Alice, the 2 is Bob. So Bob's delegate, if it is non-zero, then let's say Bob has delegated to Charlie. Okay. and then Bob has delegated to Charlie. So Charlie is going to be the next 2 variable. So basically the 2 is now Charlie. So now we need to find the 2 Charlie if it matches with the Alice. So if it does not match, then we would have to if it does not match, then fine, we'll just loop it around again. So now Charlie's delegate should, if it is non-zero, then it should not be Alice. So that is what it's saying. So if any sort of loop is found, it is going to immediately like revert. All right. So then, just like we had this sender struct, and then similarly we would have this Bob struct, okay, which is Alice struct was the previous one over here in line number 69, and then line number 94 has this Bob struct. So we are going to get the details of Bob. Now, Bob's weight should be greater than equals to 1. Okay. Otherwise, there is no point delegating Alice vote to Bob. Now, Alice vote, like Alice voted with status should be changed to true because it is going to delegate its vote effectively. Now, and then Alice delegate should also be equals to Bob. Okay, set to Bob. Now, imagine like if Bob has already voted. Okay, now imagine like before Alice, Bob already voted. So in that case, we are just going to increase the proposal vote count which the Bob chose to effectively vote that proposal. So suppose Bob went for proposal number 2. So proposal number 2's vote count would be incremented by the weight of Alice, because now Alice is planning to delegate his vote after Bob voted. So now that is what is happening over here. Okay, and then so delegate dot vote. So delegate dot vote is effectively the proposal index. Okay, so that is what it is parsed over here, and then we implement it. Next, so we have like delegate dot weight. So if it does not, if Bob did not vote, okay, then in that case we just need to increase its weight by Alice weight. Okay, that's all. Moving over to the next function, which is vote. So vote basically allows the voter to vote any proposal. So now if you see the proposal's ID has to be passed in here, okay, and then we are effectively getting the details of the voter, okay, and then we should be checking if the voter's weight is non-zero, and also voter should not have voted previously, otherwise there is no meaning of like calling this function called vote. Then we would set the voted status to true, and also we would set the vote, which is the proposal index. We would also update over here, and then proposal. Okay, in that particular thing also would be implemented. Okay, so that's what is happening over here. All right. Now, functions winning proposal. Okay, so winning proposal is this public function, okay, which can be called from both outside and inside the contract. And so imagine like you need to just run through loop for all the proposals, okay, one by one. So we are setting a local variable called winning vote count, which is let's say set to 0, and then winning vote count. So imagine like in a proposal, if it goes to proposal 0 and its vote count is let's say 3. If 3 is greater than 0, so that means winning vote count should be 3 now. Now, so winning proposal is effectively P, which is like the current index, which is 0. Okay. So now again we loop it. Okay. So likewise, let's say proposal number 1, proposal index 1 has got now vote let's say 2. Okay. So previously it was 3. So 2 is not greater than 3. So henceforth again it would loop. So next the proposal 2 is like, so likewise it would constantly go on and then find out that ideal proposal, okay, which then it is going to show as an output. And then next winner name. So it is going to just using mapping, it is going to call this name, okay, of the winning proposal, which is effectively calling this this function. Okay, all right. So that's all about the ballot contract. Now moving on to the next and the final function, final contract, which is Uniswap v3 factory. Okay, so this is I would say the version 3 of the Uniswap famous Uniswap DeFi protocol. That's DEX. All right. So first of all, I would like to show that there is inheritance used. Okay. So if you can see maybe like over here, okay, it's not running anyways. So So Uniswap V3 factory contract. So factory contract basically allows anybody to create a pool, okay, and that pool has to be something which is like a pair of tokens. So imagine like USDC to USDT or USDC to your token. So there can be a pool creation possibility. The major difference between Uniswap, like from the factory contract standpoint, like V2 versus V3, we have like in V2 we had only single fee, which was for every pool, okay. But now in V3 we have got like different fee which can be set for each of those pools. So if you have like if let's say you go ahead and create your own pool, you can set a fee, okay. Previously it was all constant, okay. So that is the fundamental, I would say, difference. Okay. Apart from that, we have a couple of other things, like you can see the fee amount tick spacing. So corresponding to each fee, we have this tick spacing thing, which is like price tick. Okay. So there has to be this sort of gap between each price possibility. Okay. So they have set some I would say limit to that, which is 16,000 around. I'll come to that in a bit. But yeah, starting with again like Solidity version 0.7.6, that is what it this Solidity, this contract essentially is compatible with. We have got a couple of imports here, okay, which is interfaces, and then we have like no delegate call, which is previously there was delegate call, which in this case, and there has been a little bit of security compromises, which in this contract it is trying to avoid. Okay, moving over to the logic part. Okay, so we have this Uniswap v3 pool deployer, which contains some of the functions which helps in sort of creating a new contract. Okay, so we would be using a function called deploy. I think that is taken from this contract. Okay, so we have got a couple of state variables: owner, tick, fee amount, tick spacing, and then get pool. Okay. So owner is pretty straightforward, which is of address type, okay, and then we have like fee amount tick spacing, which is like mapping, and then it has got from unsigned in 24 to in 24, okay. Got it. And then we have got the third one, which is get pool, which is triple mapping, okay. Ideally, previously this part was not there, okay. This fee amount part was not there. So as we can see that we have this unique fee setting feature in V3. So that is the reason that we have triple mapping now. So token 1, token 2, and then the pool address, okay, whatever is created. All right. So moving to the constructor function. So constructor function, whoever is going to be the caller, the person is going to be the owner effectively. And then owner changed from address 0 to, so this is the first time owner changed to the caller. And then fee amount tick spacing has been set for 500, 3,000, and 10,000 to 10, 60, and 200 respectively. So if you see, it is like sort of multiplier by 50. Okay. So if you multiply 10 by 50, so you get 500. Okay. So everything if you multiply by 50, so that is the sort of relation between between like 10 and 500 and so on and so forth. All right, and corresponding events are also emitted. You can see. Okay. All right. So moving on to the next function, which is a create pool. So create pool allows anybody to create, a pool. Okay, and that is what is happening precisely here. So you can see the required token amount. So those token addresses should not be equal. Secondly, you can see that there is this one-liner, okay, which is just comparing token A and token B, okay, and that's all. And then we can actually have this token 0 and token 1, which is like sorted in, I would say, increasing order. So that is how we can actually, check for if token 0 is non-zero or not. And it would automatically mean that token 1 would be, sort of non-zero because token 1 is greater than token 0. And then we would take the tick spacing from here, okay, and then tick spacing, we would check if it's non-zero. And then secondly, we would check if the get pool for the token 0 and token 1 and the fee is non-zero or not. Okay, it should be 0. Okay, it should be 0 because otherwise there is no meaning of creation of another pool for a token pair. All right. So now here is the deploy function, which is effectively like calling this, and then we can see that get pool function. I am running out of time, so I'm fast. And then we can actually do this thing as well, where sort of ensuring that we have the reverse order follow. Second is the set owner function. So set owner function is does this owner can only set this, and enable fee amount. We can have this tick spacing thing. So we can see that for a fee we can set some tick spacing. On the owner can call this, and fee should be greater than 10 to the power 6, and then tick spacing we have like 0 to this limit, and then we have like required fee amount. which is which should not be which should be 0. Okay, and then that's all we're done. All right.